So today we are going to start our next section out of chapter 4. It's going to be section 4.4, graphing sine and cosine functions. For today, if you were a B grouper, you got the Spaghetti Lab packet last week. For you in-personers, you just picked it up today. So you need that out. If you didn't print it out yet and have access to a printer, for those of you at home, please do so, because otherwise you're going to be totally lost on today's activities. So please do that as soon as possible within the next like two to 3 seconds. Okay, print that out. It's on It's Learning. Also at home, you're going to need a piece of uncooked spaghetti. I have it here for you guys in person, but we're going to get to that in a little bit. Okay. So on top of those two things, the packet and the uncooked spaghetti, you also need your notes out too, because we are going to be taking other notes today that won't be in the packet. Okay? All right. In the packet are also 2 worksheets. The first worksheet is not very good, because for some reason the even numbers didn't copy out when Mr. Roth copied it. So, but we won't get to that today yet. So when we get to those type of problems, we'll have you fill those in. More than likely that'll be tomorrow-ish is when we'll post those, what those problems should be. Those of you joining us on the line, those are the good versions, or the versions with all of the problems there are on It's Learning and can be used for your viewing pleasure. Okay? So, it was a short week last week, but we also had a test for you to do. So I just checked about 10 minutes ago, and there are still 20 plus people that have to complete that test. So please, if you are one of those 21 people that have to get that test done, make sure you get that test done today. Okay? You had over a week to do it, and you had class time last week to do it in, so there is no excuse why it shouldn't be done by now. Okay? The rest we've already talked about. All right? So let's get at it. Okay? So let's recall the sine function. So the sine function in trig has an independent variable, and actually, I mean, let's be honest, this is both sine and cosine. They both have an independent variable that is the angle measured. It's what you put into that function. You put in an angle into that function. So far, we've been working with the unit circle. And we've been saying, the sine of pi over 6 is 1/2. So the input, the independent variable, was the angle, pi over 6. The output, actually I should put input down there right away too. The input. The output, the dependent variable, has just been a number. So we put in a number, or excuse me, we put in an angle, we get out a number. Okay? So the y part of the ordered pair represents the sine function, the sine value of the inputted angle. Or, I mean, truly, it would be the y part of the ordered pair would represent the trig. Instead of saying the sine value, let's say the trig value there. I think the trig value is a better saying there, because then we're dealing with whatever function we're dealing with. I think trig value is best said. So if we want to graph the sine function, y equals sine of x, okay, again, our independent variable would be the angle. Our number would be the output. Okay? And so then our xy plane would be, we would have negative angles here. We'd have positive angles here. We'd have positive numbers up there. I should make that be a little better. We'd have positive numbers up there, and we have negative numbers down there. That's how we would have it be, the axes would be labeled. What we are going to do today is we are actually going to graph sine of x and cosine of x. And we're going to be using the Spaghetti Lab sheets. Okay? So, so here's how it's going to be. Okay? I got to get out some spaghetti for you. This is where we're going to come to spaghetti, or where we're going to use the spaghetti. You'll get one piece, and you'll get a piece. You get one piece. Okay? So, on the unit circle, sine is the y value, correct? Okay? So what we need to do is, and I think that your unit or your spaghetti labs are labeled in the good one. Yep. Okay. So it's 30 degrees there, 45 there, 60, 90. And what would we have? So we have 120, 135, 150, 180, and so on and so forth. Okay? So what we need is we need the y value. Grab one of those packets. Yeah. We need, and then grab a piece of spaghetti out of the bin right there. Okay? So we need the y value. Well, first off, at 0 degrees, our y value is 0, right? So I'm going to go back up here, and I'm going to say at 0 degrees, my y value is 0. Okay? Then I'm going to jump up to 30 degrees. So here's where the spaghetti comes in. So you need yourself a piece of spaghetti, which you already have. Okay? And you're going to go up here to 30. Come on. Come on. Come on. This one. Work for me. Smart work. You're going to go to 30. And you're going to measure. That one. measure that vertical distance right there. Okay. So I measured that with my piece of spaghetti, and then I cracked it off. Okay, so you crack off your 30 degrees. So do that now. Measure your 30 degrees, measure your vertical distance at 30 degrees, and you can either mark it with a pen or a pencil, and then break it off, because it's going to be easier when it's broken off, so that you have a length of spaghetti that long. Okay? Then what you're going to do is you're going to take that very piece of spaghetti and you're going to go up here to your graph and you're going to mark where that 30 degrees length is on your graph. Okay? Break it off though. Trust me. Trust me when I say you got to break it off. Okay? Because now you're going to go do the same thing, but now at 45 degrees. So you got to do another measure at 45. And then you're going to take that up, and you're going to bring that one up here, and 45 is going to be halfway between 30 and 60, and so you're going to put your mark there. Then you're going to do it at 60 degrees. You're going to bring that one up to 60. At 90, it's all the way up to 1. So we know that. Okay? And then now what I would like you to do is I would like you to continue that all the way around the circle. Positive ones are above the x-axis. Negative ones would be below the x-axis. But continue so that you go all the way around your unit circle on the page. So you should have a collection of points that looks like this. Okay? And if we connect those dots, we would get then I don't have the projector. We get the first lap around the unit circle sine curve. We call it the sine wave. We'll actually call that the first lap wave. Okay? Now, this would continue on it actually goes on forever and ever in both directions. Okay? Following that same pattern. But that maroon thicker band there, that thicker curve part, that's the first complete wave. Okay? We'll get more and more in depth with that in the next couple of slides, but I wanted you to see that first lap wave. Okay? All right? Packet spaghetti. Yep. Yep. You only need one piece. You have that. Just one piece of spaghetti. Okay? Good? All right? Now, let's go to cosine. Okay? So cosine on the unit circle is the x values. Okay? So I'm going to do the same thing that we just did, except now instead of measuring vertically, I'm going to measure horizontally. So at 0 degrees, I'm horizontal. My horizontal distance is 1. So I'm going to start at 0. I'm going to measure out 1. At what? Because that's the distance from here out to my curve horizontally at 0 degrees. Yep. Because now instead of measuring vertically, which was sine, now we're measuring horizontally. Okay? All right? So then, now here's where it's easier for you because you just have pieces. I got to deal with spinning oops, that's not 30 degrees. This one's 30 degrees. So then you got to measure this horizontal distance there. And then that's got to be spun now. This is where I had issues before. Because it's got to be spun. That distance right there. Okay. So then that's got to be spun, and then where I need to go. And so then at 30 degrees. Right there. Whoa. Well, that's because you just literally just got here. Okay. And then rinse, lather, and repeat again for your 45s, your 60s, 90s, all the way around the unit circle again. Okay? So do that one again now for all of them. We're measuring horizontal distances to our points, and we're transferring it to the graph. So you should have it looking like this, or your dots, and then if we connect them again, our first lap, I don't know why I always started that side. I started this side and make my shells. Our first lap would look like that of our cosine curve. And again, it would continue on. So that's all the way around. That's all the way around the circle. Yep. Yep. The thicker part is all the way around the circle. Yeah. If we continue it on, then it becomes the function. Yep. Yep. So that would be the first lap wave. All right, let's explore these functions a little bit more. So now we're going to keep your sheet out, but now we're going to be in your notes. Okay? Okay. So here is my sine of x function. Okay? But truly, this function goes on forever and ever. Because if I have sine of x, okay, that function goes on forever and ever and ever. Okay? Keeps going on, keeps going on, keeps going on in both directions. Okay? So, some observations that we have based off of that. If you're dealing with a sine or a cosine function, the domain is always going to be all real numbers. Okay? Always going to be all real numbers. In your notes. Notes. That's homework. Yeah. Yep. Okay? Always going to be all real numbers for the sine of x. Okay? If you wanted to write it as an interval notation, that would be an interval notation. Okay? Range. We know the range of sine. We did it in the obviosities when we were dealing with the unit circle. What's the smallest that sine value can be? Smallest value of sine. On the unit circle, sine is what again? Y's. So what's the smallest y value that we see? -1, right down here at the bottom, right? Okay. So my range would go from -1 to my biggest value. What's the biggest value of sine? +1, right? So sine is always between -1 and +1. We learned that when we were developing the unit circle. Hasn't changed yet. Okay?
Is there a difference at all between the function lines of sine and cosine?
Yes.
Okay.
One has it's a horizontal shift of pi/2, but we'll get to that tomorrow. Okay? So, with that being said, with my range being -1 and my +1, the highest that my value can get would be +1. The lowest that my function could get would be -1. What's in the middle of those two numbers? 0. Okay? So the middle of my function would be the average of those two numbers. Okay? So that would be 0. Okay? Now, the amplitude has a definition, and it is the true definition of amplitude is the height of your wave. Okay? That's the definition of an amplitude. It's the height of your wave or the height of your curve or however you want to call it. How we find it is the distance from the low to the middle or the middle to the high point. Okay. So that's the amplitude. So if I go back to my curve up here, okay, so my middle line is right there. My high line is right there. My low line is right there. So the amplitude would be the distance from low to middle or from middle to high. Okay. Well, if my middle is at 0 and my high is at 1 and my low is at -1, what are those two distances? 1. Okay. So in this particular case, my amplitude would be 1. Okay. Now, start and end. Technically, these curves don't have a start or an end. Because they go on forever in both directions. Okay? We are just going to talk here about the first lap wave. Okay? So that's the start value that we want. The first lap wave start. Okay? So that would start right here at 0 because my unit circle starts at 0. Then it's going to go all the way around the unit circle, and that's going to end at 2 pi. The period is the horizontal distance to make one complete wave. We find it, it's very easily found, the period is equal to the end minus the start. So in this case, the period would be 2 pi. It takes me 2 pi units to make one complete wave. Okay? So I would start there, and I would end back at the same spot. Okay. Now, if you'll notice, sine starts in the middle, then it goes to the high point, back to the middle, then down to the low point, and it ends in the middle. That pattern will be true for all sine curves. Starts in the middle, goes to the high point, back to the middle, down to the low point, ends back in the middle. So those are some observations of the sine graph. The cosine observations are very much the same. Okay? So the domain of our cosine graph is also all real numbers. The range of our cosine graph is from -1 to +1. We have a high value of +1. We have a low value of -1. And we have a middle 0. All the same as the sine. Amplitude, distance from middle to low or middle to high, is also 1. Here's the start of cosine. There's the end of cosine. So the start, yeah, that's great. Here for why not? Downloading and installing software. So my start is at 0. My end is at 2 pi, which means my period would be 2 pi. What's on here? Okay. The only difference with our cosine curve is that if you'll notice, our cosine curve starts at the high point. Then it comes to the middle. Then it goes to the low point, back to the middle, and it ends at the high point. So sine starts in the middle, high, middle, low, middle. Cosine, high, middle, low, middle, high. All right? Let's start graphing some cosine and sine functions. Again, this is in your notes. This is not on the worksheet. The worksheets are for your extra practice later on this week. You are not able to do any of those problems quite yet. So let's start graphing them. We're going to be transforming those two functions now. So we've got these different values. We've got A values, which we'll focus on today. We've got B values, which we'll focus on tomorrow. C values, which we'll also get to tomorrow. And we've got D values, which we'll get to on Thursday. Okay? We are only going to ask you to do one wave. So we're just going to show you one wave, and I'll get to those here in a minute. But what A does, A stands for amplitude. Okay? It is our vertical stretch. Okay? So it expands it vertically or it condenses it vertically. Okay? That's what the A value does, and that's what we're going to focus in on here in about 5 minutes. Our B values, or if you have a B value there, that is going to be your horizontal stretch. It's like an accordion. It's either going to expand the accordion out or it's going to push the accordion together. That's what B does. C is our horizontal shift. So that's going to take the whole function and pick it up and move it horizontally. Okay? It's going to keep it rigid, but it's going to move it horizontally. And our D value is going to be our vertical shift. So again, it's going to pick the whole thing and move it up or move it down. One of the two. Okay. And so what we're looking at is we're looking at that first lap weight. So we're going to take all those parts and we're going to move them. We're going to shift them. We're going to move them around. Okay? So let's focus in here on A, amplitude. Okay? Again, our amplitude A is a distance. So since it's a distance, it is always positive. Middle to either the top or, not the top, the high, I should say. The high point or the low point. Okay? That's what the distance is. The A value is going to control, in your graph, it is going to control the high point, the low point, and the range. Since the range is made up of the high value and the low value. We like to have, what are there, 2, 4, 6, 9. There's 9 things that we like to find before we go to the graph from each function. Okay? And for today, most of them will be the same. As we get more and more into B's, C's, and D's, then they'll all be shifting a little bit. Okay? But for all of them, for all sine and all cosine functions, the domain is all real numbers. Okay? Automatically, all real numbers. This particular sine function has an A value of positive 2. That tells me that my amplitude is going to be 2. Since there are no other shifts in this graph yet, because we're just starting, our middle is going to stay at 0. So if my middle's at 0 and my amplitude is 2, that means my high value is at 2, my low value is at -2. That tells me that my range then is -2 to +2. Okay. So I get all of that out of my amplitude. Now, later on, when we have vertical shifts with D, that D value is going to change your middle, which then that's where you start and then add your amplitude to it to get your high point, subtract your amplitude from it to get your low point, and then that affects your range. Yes? Until we get B's and C's, our start is going to be at 0, our end is going to be at 2 pi, and our period is going to be 2 pi. Tomorrow, when we get B's and C's, those three will also change. Okay? When we go to the graph, and you will have to graph in this unit. I'll tell you this right now, because this unit is all about graphing trig functions. And so your unit test for this section will include graphs that you will have to produce and turn in separately from the online test. Okay? Like a homework, you'll have to turn in the graphs separately also, because there's no way that we can replicate this on its learning. Okay? So how I would graph this one? It's a sine function. So since it's a sine function, it's going to start in the middle, go up high, back to the middle, down low, and end in the middle. I start with my curve, my lap, my function. Okay? I start with it. Then I have to go in and I have to label my axes. Okay? So my high point is 2, my middle is 0, my low point is -2. And it doesn't have to be precisely exact. Okay? Then I've got to do my horizontal axis. I started at 0, I ended at 2 pi. Halfway would be pi. Halfway would be pi over 2. Halfway would be 3 pi over 2. Those 8 labels are required on all of your graphs. Okay? Those 8 on all of your graphs. And that's what we need to have then. That would be our final product. Okay? Let's try one with a negative A value. So we have positive A values, we have negative A values. So here's a cosine curve with a negative A value. Okay? Sine curves look like that with positive A values. Cosine curves look like that with positive A values. With negative a values, those both flip vertically, or they get reflected, is the true term, vertically. So a negative a value sine function would look like that. A negative a value cosine function would look like that. Okay? So just so you know. So the domain of our function is still going to be all real. Amplitude of our function is going to be 3. It's the absolute value. It's a distance. The absolute value of that a. No other shifts. So our middle is still at 0, which means we go up to 3, down to negative. No other shifts. 0, 2 pi, 2 pi. So because it's a negative cosine, we're going to flip it over. So instead of starting up high, we're going to start low. It's going to look like that. Filling in, we'll fill in vertically first. Negative 3, 0, positive 3. Until tomorrow, those will be our 5 horizontal ones. Questions, comments, concerns? Went too fast? Yeah? Try that one. Try that cosine curve on your own. So, it's all real numbers. Middle is going to be 0. Amplitude is going to be 1/2. So my high is going to be 1/2. My low is going to be negative. That so far. It is a cosine curve. So cosine starts high, ends high, fill it in, 0, negative 1/2. Again, not looking for an exact graph, just looking for the concept. You know? Making sure that you can find those points, making sure you can get the correct shape. Okay? Usually when we grade these graphs, we have 1 point for the shape, 1 point for the horizontal axes, and 1 point for the vertical axes. Okay? So that's really all we're looking for, is that stuff. You know what I mean? Not looking for precise things. Okay? Any questions about that? think I've gone on long enough. I think that's a good ending spot for today. We'll pick this up tomorrow.